So now let's do the derivative by first principle on negative powers. Oops. So we have to find the derivative with respect to the independent variable of this expression, and the independent variable here is z, so we have to find the derivative with respect to z. So the first step is obviously to let y be equal to the expression 1 over az minus b whole to the power 7, and so we'll take this to the numerator, and this 7 becomes negative 7, and this is our equation number 1. So this first step is to take the increment on both sides. So standard procedure, on the left hand side this y becomes y plus delta y, and this z becomes z plus delta z, and you'll take this positive y to the right hand side where it becomes negative y, and this z z plus delta z will be multiplied with a, so this becomes az plus a delta z, and this minus b remains as it is. And so you'll take this, you put this az and this minus b together over here and add that to a delta z, because we have to take the binomial expansion of this later on. So this is our equation number 2. The second step is to put the value of y from equation number 1 in this equation number 2. So this y will be replaced with az minus b whole to the power minus 7, and to apply the binomial expansion over here, you'll take az minus b whole to the power 7 common outside, and this az minus b inside the bracket becomes 1, and you'll divide this a delta z by az minus b, because once this is multiplied with az minus b whole to the power minus 7, this basically just becomes, this cancels out, because this whole bracket is now in the minus to the power minus 7. So this az minus b is also to the power minus 7, and so if you just know basic algebra, you'll know how these cancel out. And so you'll basically also take the az minus b whole to the power 7 common from this term over here, and so this entire thing turns into one bracket, which is this. And so you'll expand this term by using the binomial series, and so this is the negative one that came that is not part of the binomial series, and this is the binomial expansion of this term, and this positive one and this negative one will cancel out because they are being subtracted from each other, and so you're left with this. Now there is at least one delta z term in every single term over here that's being added up. So for example, this is 1 delta z, this will have delta z squared, the next term will have delta z cubed, and so on. So we'll take 1 delta z common from each expression. So step 3 is to divide both sides by delta z. So you'll have the left hand side as delta y by delta z, and the right hand side will also be divided by this delta z, and so this delta z and this delta z in the denominator, they will cancel out because they're in a fraction. And so you'll take the limit as delta z approaches 0 on the left hand side and the right hand side. So this left hand side becomes the expression for the derivative of y with respect to z, and on the right hand side you'll apply this limit as delta z approaches 0. So every delta z term in the right hand side will become 0. So every single term after this first term, which is this one here, every single term after it that's being added up will have at least one delta z term. So for example, this term has one delta z being multiplied, the next will have delta z squared, the after that will have delta z cubed. So every single delta z there will be at least one delta z term in each thing added up. So once you apply the limit as delta z approaches 0, every term will be multiplied by 0, as there is at least one delta z term, except for this term. So you'll just be left with this term only, because the other terms will just become 0, and hence yes, what you'll do now is you'll take this az minus b whole to the power minus 7, you will turn it into 1 over az minus b whole to the power positive 7. So once you do that, it will go into the denominator and be multiplied with this az minus b over here, and so az minus b 1 plus 7 obviously, and the numerator will remain as it is, minus 7a, and so you'll get this as your final answer.